Hi to everyone. This is Shashi Pandey from Maharaja Surajmal Institute and the Prastha University, Delhi, India. I'm very happy to present my work this online conference Voices 2019. And thank you for all the organizing team for giving me the opportunity to present my work in this particular conference. Uh, in this presentation, I will discuss my new work, especially based on uh, musical approach in teaching, or you can say a rhyming approach in teaching. Before that, I want to say that I will also discuss that how the technique of rhyming and poetry is very helpful in classroom teaching and learning process. Okay, so in this slide, I'm just presenting all those bullet points on which further I will say. First one is edutainment. So this term is basically very much trending in teaching and learning process because the domination of digital age in teaching and learning process is motivating us to work in this direction so that how we make so much efficient our teaching and learning process using the digital technology. Next, I will show you a research work, especially the effect of musical training on the academic performance of students. I have taken all those data from a specific paper, which is already published just 2-3 months before. Next, I will present some results regarding the connection between music and maths, and finally, I will show you the rhyming based on mathematical concept, which I have written earlier. So I'm starting with a very interesting quote by Leibniz, Hardy, and Gardner. They are very famous mathematicians or scientists in this world. Leibniz have uh, written in his book that music is the pleasure the human mind experiences from counting without being aware that it is counting. So it represents that how interesting the area of music and mathematics both are interrelated. Next, I am quoting G. H. Hardy's statement that mathematicians' pattern, like the patterns or the poets, must be beautiful. So more or less, we can easily see that in mathematics, we are also trying to find patterns. We are also questioning that which type of pattern and how I'll guess the pattern. And in fact, in poetry writing, people are also trying to find patterns and connection between words. And next one is Martin Gardner. It is very famous columnist of Scientific American. So he had written that a surprising proportion of mathematicians are accomplished musicians. Is it because music and mathematics share patterns that are beautiful? So more or less everyone, every big name in this particular slide directing towards the connection between music and maths. In this slide, I, I'm presenting the very famous quote by Pythagoras. And especially, I like this particular quote. That's why I presented it in a single slide. There is geometry in the humming of the strings. There is music in the spacing of the spheres. Anyone can understand that how a musical instrument is satisfying different type of patterns of geometry, and how mathematical object like sphere, circle, and all different geometrical objects have a special type of pattern inside it. So these could also motivate us to find the connection or to do some work in the direction of maths and music. Okay, so now the term edutainment basically contains all those ideas or all those techniques which we are using to make efficient teaching and learning process. So there are various research papers and research work done in this particular area, but still the innovative part is still on for everyone. The music is especially a very interesting area because everyone have a bit of interest in different type of music, and it will affect a very positive weigh on our brain. So we can say that if we are using music or rhyme or poems in classroom teaching, in learning process, then obviously it will present better result in the classroom, and in fact for students also. In next section, this is ancient rhyme practice. Here I am quoting a reference paper written by Black and its team member. In this paper, he had presented the poetic connection of mathematical activities of these very ancient societies, Sumerian, Akkadian, Babylonian. So there are so many evidence that how people uh, were using at that time also the rhyming practice in um, presenting mathematical ideas. Next is the example of a very simple um, use of rhyming technique in understanding the multiplication table of two. So, at the age of childhood, we also learned about the table of two by this particular rhyming techniques, because whenever we are trying to read this loudly or continuously, then we can see that rhyming is already coming in the reading of this particular table. Two ones are two, two times two is four, two times three is six, two times four is eight. So obviously the word are repeating in this particular table, so we feel that there are some rhyming. So why not these type of technique people use in their teaching practice? That if we write those statement of theorems, results in rhyming form, then it is hard. It is hard to forget yeah, those results in future also. This one is the result of the research work. This paper, I have mentioned this paper in my reference area. So this work is published very recently, in fact, in 2019 June, in a journal of, in very reputed journal of America, journal in America. And this particular work is based on that how the musical training or how the previous musical background of student may affect his or her grade in these subjects like English, maths, and science. So you can see that in this particular statistical result, the author has claimed that participation in instrumental school music and participation in vocal school music. So he compared these two results and he obviously presented this particular marks. So you can see that those students who are participation in instrumental school music have greater marks than participation of vocal school music. So in fact, uh, this type of learning of music, like whether it is vocal learning or it's instrumental learning, so it will also affect the uh, grades of students in different subjects. It is very interesting that to pursue this particular idea for students and for teacher also. So motivated from all these ideas, I have written some poems on mathematics, mathematical ideas. So this is the first poem based on circle. Before that, I want to here I want that I want to present a song uh, presented by my student Ashutosh based on central tendency. The lyrics written by me, but the particular song is made by Ashutosh. So I want us that a glimpse of this particular song to play. Listen. Let's talk about central tendency, center of the mass of an object, a point having the hypothetical prospect, uniform density, referred at the centroid. In another case, it may be outside. We analyze data by its central vacancy. Mean is the primitive central tendency. Mean involves every measurement. Median and mode are its replacement. Zero is the sum of deviation from the mean. Its validity for other measures unseen. Let's talk about central tendency raised by the presentation of this poetic sense of mathematics. Okay, so here the mini poem, it is based on circle. So every statement I have used which present some mathematical ideas of circle. I won't just read it because this time I can't say that I sing like this particular musical presentation. Okay, so the first line is as follows: we are surrounded by various symmetry. A circle has a center with equidistance boundary. Distance between boundary and center is radius. After its measurement, the circle becomes less tedious. Because obviously, if I'll measure the radius, then the approximation of the area of the circle. A circle on a plane divides interior is inside and exterior is outside. Interior with boundary is called disk. Explore about the idea of the unit disk. Math of circle motivated from astrology. Everywhere we are using its technology. Length of its boundary is called perimeter. Twice of radius length is its diameter. Squaring the circle is an ancient problem. Many mathematicians had tried this random. Find the perimeter when the diameter is sure, how their ratio always lies between 3 and 4. It is very interesting case that when people are trying to approximate the value of pi, so this refer to this particular problem. This line is referring to this particular problem. The area inside the circle is still a mystery. Archimedes approximated it by polygon's trajectory. The area of a disk is proportional to its radius squared. The proportional constant pi is still not fully measured. Pi is always there in the area approximation. Babylonian had used 3 as its rough estimation. Size of stanzas fit with decimal expansion. In last two lines, that I want to convey that initially Babylonian society were using the value of pi to be 3, and it was just rough estimation. And the last line referred to the presentation of this poem because the bunch of lines in this poem representing the value of pi. 3 lines in the first bunch, 3 lines, next 1, 4, so 3.141, 5, and 9. Similarly, I have written especially for pi. Let us come together to start the theory of pi. Start from 3 with unending random number supply. Astronomers are dedicated to make it traceable. Transcendental nature make it more mathematical. The ancient Babylonian approximated by 3, the area of circle become less error-free. Obviously, this was very interesting problem. How to approximate the area of circle. In fact, still it is an open problem, you can say, because we have only the approximation of pi. So we can't say that this is the exact area of this particular circular shape. Pi is there in the shape of circular creature. Thrice of diameter approximates the associated parameter. Archimedes had bounded this approximation. It is the first available mathematical calculation. So in literature, the method of Archimedes to approximate pi is still available. His estimated idea was best among available paragons. He sandwiched circle between inscribed and subscribed polygons. So in this way, we can present that what idea actually Archimedes used to approximate the value of pi. His estimated idea was best among available paragons. He sandwiched circle between inscribed and subscribed polygons. Zhu Chongji tried with similar approach for solution. His approximation was not surpassed for a long duration. No matter what side circle you drew, circumference divided by diameter remains fixed for free. So I want to convey with this line that Zhu Kongji have also, he is Chinese mathematician and he had used a similar approach to approximate pi. And in next line that if you are trying to approximate the ratio of circumference and diameter, and obviously it is a constant number pi which will fix for every people in classroom. If you are trying to present a mm, mm, experiment in this particular classroom to measuring circumference divided by diameter. It is available in the sum of the infinite series. Madhava of Sangamagrama proposed these theories. Estimation of irrationals done by mathematicians, inverse of pi enumerated by Ramanujan. So when people are trying to explore various infinite series, and interestingly, they are getting the sum of these infinite series approximated by pi, then it is also very interesting results. And Ramanujan has proved that a specific type of series have summation equal to 1 by pi. So I am presenting that inverse of pi enumerated by Ramanujan. And last line again, size of stanzas fit with its decimal expansion. So in this poem, also the bunch of length of sentence in a bunch will present the value of 3.1414159. Next is based on a very interesting number. It is E, and it is based on the name of Euler. So this poem is: infinity is a limitation of normal eyesight. Construction of infinity is a mathematical fight. Irrational numbers are eternal objects. They came from geometrical project. Here I want to convey that the non-ending random numbers we are getting from irrational. So that's why it is like an eternal object. And they came from geometrical objects because they are very, very interesting type of geometry connected with irrational numbers, like how pi is connected with circle, how root 2 is connected with the diagonal of a unit square, and various other ideas. Idea of proportion is rational number. Irrationals are not the ratio of integers. So here I want to convey the definition of irrationals. Pi, root 2, and e are their initials. Geometry makes them practical. Through geometry, we can see the practicality of those irrational values. Napier, Outred, Bernoulli, and Leibniz attempted the same practice. They are some very famous mathematicians who have presented that how those irrational numbers connected with those various geometry, that how pi is connected with circle and root 2 is connected with the unit square. E came first time in an unpublished paper. Its credit goes to Mechanica of Leonhard Euler. So Leonhard Euler have written this particular manuscript. It is named as Mechanica, and in this particular manuscript, he proposed the notation E for particular constant. So this is the first time where this particular constant have named as E, and after that we are still using this particular constant. That's why I have mentioned that E for Euler. Thanks to Euler's identity, irrationality of pi is its guarantee. Euler's identity is e to the power I pi is equal to 1. And in using this identity, we can easily show that pi is an irrational number. Bernoulli connected E with compound interest. Continued fraction was the Euler's quest. So it is a very interesting story that how compound interest problem motivate Euler to find the constant E. That's why I have presented that 1 plus 1 by n to the power n is money gain in finite time. Its continual measurement is Euler's prime. So the Euler's number is E, and the measurement of this particular compound interest will give you a particular value of E. You can present in front of students so that they are getting the idea of actual story that how Euler motivated with E. Y is equal to e to the power x have unique assessment, area under curve, value, and gradient. So here I want to convey that y is equal to e to the power x. If you draw the curve of this equation, then you can find that this equation have this particular constant for every point. It means at any point on this curve, the area under this curve, value at this particular point, and the gradient at this particular point, all are equal at any point of this curve. So this is the last poem in this presentation. These are my some recent work based on the poetry writing of mathematics. It is based on prime number, prime time. Another one is triangle. It is based on the property of triangle. And it is my blog. In this, you can find my other poems. Yes, this is a central tendency. And this particular lyrics is that poem. And similarly, you can find other poems: cryptography, simplex method, Carmichael number, circle, real number, Heron's formula. This now this is the reference slide. You can see that there are very latest work with this particular paper. M. Goon, he actually it is PhD in this particular area, that how musical training can affect the academic performance of students. Thank you very much. Thank you very much to hearing me, and thank you very much to organizing team of Voices 2019. And it is very interesting initiative to motivate students toward learning of scientific ideas with various innovative techniques. Thank you very much.